Good morning, students. Now we will discuss about digital frequency meter. Digital frequency meter. That means how the frequency is measured by using a meter. Here we are having simple block diagram for a digital frequency meter. Now I will explain each and every block and how to measure the frequency by using this existence. And before starting to our topic, first of all, we had to know about each and every block in this block diagram. Here it is amplifier. The purpose of amplifier is it will increases the strength of the applied input signal. It is a Smith trigger. Smith trigger. The purpose of this Smith trigger is it will convert the applied input to square signal. And it is 1 megahertz crystal oscillator. It will provide sinusoidal signal. The output of crystal oscillator is given as an input to the Smith trigger. Here also this Smith trigger converts applied input signal to square signal. Square signal. Here it is 1 megahertz signal. 1 megahertz signal. Now when we pass this 1 megahertz signal through these divisions, frequency divisions, then we will get the corresponding time slots like this. That means actually 1 megahertz frequency means that is equivalent to 1 microsecond of time, because we know that the formula of T equal to 1 by F. T equal to 1 by F. That means inverse of the frequency is nothing but the time period. T equal to 1 by F. That is the frequency. And now when it is divisible by 10 in the next slot, it will become 10 microsecond. It will be divisible by 6 times. Then it will become 1 hertz, that is equivalent to 1 second. 1 second. These are the different time slots we are having. These time slots can be chosen by this time base generator. That means how much amount of time the gate should be open. The time is selected by this time base generator. Now by using this time base generator, we are selecting any one of the time slot. For example, this one, like this. We can select any one of the time slot by using this time base selector, and that amount of signal is given to the Smith trigger. Then the corresponding time slot signal is generated by this Smith trigger. Smith trigger. That means by depending on our applied time here, the Smith trigger generates the corresponding signal. And that is given as an input to the main gate flip-flop. Whenever it will becomes, it will send a signal to the main gate. Here generally this main gate is AND gate. We know that the basic operation of AND gate. AND gate operates only whenever the two applied inputs are high. So when the input comes from this is the one of the high input, and another input comes from this, it is the high input. Whenever those two inputs are high, then the corresponding gate will be open. Then number of samples is counted and displayed here in decimal display corresponding to the samples. For example, here n number of samples are generated. So the frequency F can be calculated as F is the n number of samples, n divided by how much amount of time slot we have selected here. For example, if we have selected 1 millisecond, like this. For example, if we are getting 10 samples, n equal to 10 samples we are getting here, then 10 by 1 milli, that means 10 into 10 power 3, that is equal to 10 kilohertz. 10 kilohertz, that means the applied input signal frequency is 10 kilohertz. That means By depending on the number of samples and applied input signal, the corresponding frequency value is calculated. It is about digital frequency meter.